Hello! In this WAGO tutorial, we're going to walk you through the basic settings in WAGO Load Management and demonstrate how to add meters. We'll be using a charging park simulation running on a PFC200 as a CodeSys 3.5 visualization. In the same network, there is a CC100 with WAGO Load Management installed and licensed for 5 charging points. The simulation includes 3 meters for grid connection, PV system, and building, along with 5 charging points. Since the simulation runs on a PFC, all meters and charging points share the same IP address and are addressed by port in this example. In a real-world system, you'd have different IP addresses since typically each meter or charging point is a network participant. We'll start with the basic settings in the configuration menu by assigning a project name. The switch here lets you activate or deactivate the entire load management system. Next, the general settings for grid connection follow. This includes specifying the mains voltage between phase and neutral, the maximum phase unbalance, usually limited by the grid operator at 20 amps, and whether the phase unbalance should consider only the charging park or also the consumption at the mains connection. The most intriguing part here is the maximum total current at the grid connection point, which we set at 105 amps. Note that the specification is in milliamps, so that's 105,000 milliamps. We recommend entering a power reserve to accommodate short-term consumption fluctuations, 5 amps in this case, providing us with 100 amps to supply the building and the simulation's 5 charging points. If less power is available for the charging park than specified at the grid connection point, such as when the park is differently fuse protected, we can specify a maximum total charging current here. On the right side, we enter the peak power of the PV system and optionally the power specifications for a battery storage system. For control settings charging behavior, we specify how a charging point should behave if it's deactivated in the WAGO Load Management. Whether charging is disabled, possible only with minimal charging current, or if all charging current limitations by WAGO Load Management should be lifted. It is also recommended to set up a charging pause. Whenever charging is interrupted, for instance due to insufficient charging current availability, charging pauses for the time set here. This prevents a charging process from starting and promptly stopping anytime if the values fluctuate around the minimal charging current, which is an undue load on both the charging infrastructure and the vehicle battery. In a real system, the 300 seconds entered here, that are 5 minutes, are a good guideline. To illustrate the function in this video, we'll enter 30 seconds. Don't forget to save, then we can create the first meter. Naturally, the first meter is the mains connection meter. In the dashboard, we open the window for a new meter via the Add button at the top right. We assign a name and an optional description. The buttons MQTT and Modbus TCP server remain deactivated for now, as we'll cover them in further tutorials. We then select the exact meter type, in our case, a WAGO MID meter. For the role, we specify the meter's function, which for this meter is mains power supply. Depending on the role, the meter values are used differently in the algorithm. With the role display, a meter doesn't influence the algorithm. With consumption, power is drawn from the system. With generation, power is supplied to the grid system. Mains power supply is then the role for a mains connection meter. There are additional roles for batteries and EV consumption. If needed, for instance with transformer measurement, a factor can be specified here. If this is not needed, the value is 1. If the measurement value must be prepared differently, a formula or an additional current value can be entered here. We have already specified the maximum current intake in the basic settings. Our MID meter operates on all 3 phases. Communication with the meter is via Modbus TCP, but Modbus RTU or network meters are also possible. We provide the IP address of the PFC200 running the simulation and check for the port on which the grid connection meter communicates in the simulation, port 1401 in this instance, which we enter here. We leave the slave ID at 1 and maintain the whole TCP connection to monitor communication with the meter. Otherwise, WAGO Load Management would continue with the last available value upon connection loss. Don't forget to hit save and the grid connection meter appears in the dashboard. Next, we'll create the PV meter in WAGO Load Management. We could add a new meter through the button at the top right and enter everything anew, but there's also a possibility to duplicate the grid connection meter. Then, only the differing data needs updating. Name and description. The role is generation, and the port is now 1402. Save, and both meters are now displayed in the dashboard. Similarly, we add the building's consumption meter. With all simulation meters set up, let's move on to the charging points. We'll delve into the charging point configuration in a detailed video later, so we'll skip over several fields here. Using the Add button, we open the new charging point window, assign a name, and provide an optional description. The wallbox used in the simulation is a Heidelberg Energy Control with firmware 2.6.4 and Modbus. The minimum charging current defaults to 8 amps and the maximum to 16 amps, common in practice. The wallbox is connected in a three-phase manner. In our instance, it's a Modbus TCP connection. The IP address is again that of the PFC200 simulation, and the first charging point communicates over port 1501. Save your changes and the charging point appears in the dashboard. The vehicle is still disconnected. We switch to the simulation, connect a vehicle at the first charging point, and it charges at the maximum current of 16 amps, as also shown on the load management dashboard. Use the duplicate function to add the remaining 4 charging points. Returning to the simulation, we observe the vehicle's charging current of 16 amps, the building's consumption of 50 amps, and summed up here, the grid supply of 50 amps plus 16 amps equaling 66 amps. When a vehicle connects at charging point 2, it starts with the minimal charging current of 8 amps, then rises to 16 amps, and similarly at point 3. The supply current is now near the maximum threshold at 98 amps. Connect another vehicle at charging point 4, and the available charging current is evenly distributed across all active charging points, charging each of the 4 vehicles roundabout at 12 amps. Connect a vehicle at charging point 5, and the charging current at each point declines to 10 amps. We slowly increase building consumption, reducing the charging current at all points to 8 amps, causing charging points to disconnect one by one. When reducing building consumption again, vehicles resume charging, albeit only after the set charging pause of 30 seconds lapses. Increase building consumption back to 50 amps, and following regulation guidelines in the WAGO Load Manager, the charging current stabilizes at approximately 10 amps. Now let's boost PV output to 30 amps, introducing more available power into our small network, allowing all 5 vehicles to charge at maximum charging capacity, though the main supply current remains at 100 amps. Further increase in PV output reduces the intake at the mains connection point, and with reduced consumption, the intake drops further until we eventually supply power. WAGO Load Management also has the feature to integrate so-called system meters to display additional values. System meters are sorted alphabetically at S in the device type selection. A popular one is the System Meter Remaining Power Charging Infrastructure, showing us how much more charging power is available. Once this meter is added, it shows at a glance that 25 kilowatts of charging power is still available, allowing another vehicle at charging point 5 to charge at maximum power. Adding another vehicle at charging point 5 reduces the remaining charging power by 11 kilowatts to 14 kilowatts. In conclusion, let's have a look at the list of available meters. Many common meters are already listed, but given the variety of device types, it's possible a required meter isn't listed, like the John Müller meter PL2. In such cases, meters can be imported via a JSON file, which can be requested from WAGO. In numerous instances, these are already available and generally released with the next firmware in WAGO Load Management, or they can be individually created. When a JSON file with the meter definition exists, it's imported through the Backup and Import menu. Simply select the file, choose the meter type, and upload the file. Now the John Müller meter PL2 is present in the meter list. And that concludes the tutorial on basic settings in WAGO Load Management and how to add meters. Please leave us a thumbs up if the video was helpful, subscribe to the channel and contact the WAGO Support Center if you have any questions.